All right, AP Calc, we're going to be doing some example problems with some trig functions, okay? We're going to eat some M&Ms. Does that sound good? No, it doesn't. Yes, it does. Who brought M&Ms? Okay, so in order to first take a derivative of any trig function, you've got to know what the derivative of all 6 trig functions is. So let's go ahead and set up our chart for our f of x and our f prime of x. Please don't look back on anything else. Just try to recreate it all by yourself all over again. Who can give me the 6 trig functions in order, please? Can you do it?
Sine,
Go ahead, Kev. Sine,
cosine,
sine of x, cosine of x,
negative x, secant.
oh no,
No.
okay.
Cotangent.
Okay, so you say a function and then you say its cofunction. So if we said sine and then cosine, tangent and then
Cotangent.
cotangent,
There's cosecant.
Secant.
Oh, secant.
secant, dang. And then cosecant. Okay, we gotta get those 6 in order. All right, sine, cosine, tangent, cotangent, secant, cosecant. Get them in order. So that after each function is its cofunction, and we've already talked about what cofunctions were. But also what it does is it sets up our reciprocal functions this way. Right? So we should always want to play with our trig functions in order. All right, now, what is the derivative of sine?
Cosine.
Good. So the derivative of sine x would be cosine x. What's the derivative of cosine x?
Negative sine x.
Negative sine x. Good. Now I know this is kind of weird, but the derivative of cosine x has to be what the derivative of sine was, but I need to use its cofunction and a negative sign in front of it. So what is the cofunction of cosine? Sine. And then a negative in front of it. Where else do my negatives go? Can you guys hit that fast? Cotangent and cosecant. So when you take the derivative of any cofunction, the answer is negative. Let's keep going here. You got to know the derivative of tangent x. What is the derivative of tangent x off the top of your head?
Secant squared x.
Secant squared x. So I got the negative here. Now give me the cofunction of what I just wrote for tangent.
Cosecant.
Cosecant squared x. And what's the derivative of secant x? Something. Secant x tangent x. That's why she won. Isn't it weird that the derivative of secant is actually inside itself? Has the secant function embedded in it? Okay. And what is the derivative of cosecant x?
Negative cosecant cotangent x.
Okay, so negative, say it one more time.
Cosecant x. Tangent x. Oh, cotangent.
So you see the pattern? Is everybody catching a pattern? I know you gotta know a couple of them to begin with. You have to know that, you have to know this, and you have to know that. But then you should be able to figure the other ones out relatively easy.
Bless you.
Bless you, bless you. Okay. Okay. So, let's start with something simple. I'm going to, let's see, example 1. I want the derivative with respect to x of sine of 5x. I'm going to do this without actually doing any quote-unquote view substitution, which we'll get into quite a bit, but right now, let's just get this M&M idea down. So what is the derivative of the sine function? Cosine. Okay. So the derivative of sine of 5x is going to be cosine of 5x, but then I need to chase it. I need to chase that with the derivative of my oogie boogie that's inside there. So I have a 5x in the parentheses. What's the derivative of that 5x? 5. So then I rewrite this and it ends up being 5 cosine of 5x. Be a little different this time. what is the derivative of sine of x cubed? Sine cubed x.
3 cosine x.
Very close, very close. Let me just rewrite it for you first before I do this. You know how sometimes in order to use the power rule, we like to rewrite things so that it looks like the power rule? That's what I'm gonna do here. So I'm gonna rewrite this as sine of x quantity cubed. What would the derivative of the sine of x quantity cubed be? So I like your idea about that 3 coming down. This exponent right here comes down out in front. I'm using a power rule.
Cosine.
Cosine squared.
Yeah.
Okay, so I need a square. So 3 something squared. The thing here, your oogie
Sine
boogie,
x.
does not change. However, we now need to chase it with the derivative of our oogie boogie. What's the derivative of sine of x?
Cosine.
Cosine x. And then we can write that a little nicer, and we can just call it 3 sine squared x cosine x. With both of these problems that we have up on the board, we have the chain rule occurring once in each problem. So you can see if I just have a regular trig function and I can just take its derivative directly, then I have to see what my angle measurement is and take the derivative of the angle measurement, and then I'm finished. If my trig function is being raised to an exponent, then my major concept here would be the power rule. And inside the power rule, the base, the sine of x here, has to get copied in order to do your power rule, and then you chase that answer with the derivative of that oogie boogie. And you end up with actually 2 trig functions. Now, you're gonna, I hope, not be too confused as to when your trig function is gonna disappear and when it doesn't disappear. But if I rewrote this the way I rewrote this one, as a matter of fact, I will just for a minute, but you should have been fine with what I said here. This is the derivative with respect to x of sine of 5x quantity to the first. Now if I did the power rule with that 1, wouldn't the 1 come down to the outside, right? And I'd end up with 1, and then I'd still have this thing here, sine of 5x to the what? To the 0. And then I'd have to chase with the derivative of what I have inside. Now what would the derivative of sine x be? Cosine x. So it's a derivative of sine of 5x. Cosine 5x times 5. There's your peanut. See it? So when I'm eating my M&M right here, here's my M&M, I'm crunching through here and I'm getting cosine of 5x, but now I got a little peanut in here, so I gotta hit it again. And that's my peanut M&M, which is a double chain rule. But won't this disappear?
Yeah.
Because anything that's not 0 to the 0 exponent is just 1. So that's when your trig function is going to not show up in the final answer. You see I got the same thing? Oh, wasn't it just easier to do this straight? So if you only have one of these trig functions, just to the exponent of a 1, then this trig function is pretty much going to disappear in the answer. Okay? Now, the exception to that would be the secant function, because the derivative of secant is secant tan. So no matter what, when you take the derivative of secant, you're going to see a secant again. But the other ones, when I take the derivative of sine, I don't see sine here. When I take the derivative of cosine, I don't see cosine. When I take the derivative of tangent, I don't see tangent. When I take the derivative of cotangent, I don't see cotangent. All right? So this we think of as a single chain rule. This we think of as a single chain rule. But you could rewrite this. Okay? Now, let's get busy and show you what happens when you have to do it. The derivative with respect to x again. And let's call this sine of, pick an angle.
45
degrees.
Okay, with x's. I'll make one up. me some peanut M&Ms here. So would you like to rewrite it, or are you good to go, looking at the power rule the way it is?
I like,
You like to rewrite it? So, can you tell me what to write?
D, with the, dx.
Okay, so you could say d over dx,
Uh-huh.
or you could say the derivative with respect to x. So say that. The derivative with respect to x.
Derivative with respect to, and then in brackets, it would be sine of two x cubed, and then you close the brackets.
Parentheses and brackets.
And then you have, to the fifth power.
Good. So I haven't taken a derivative yet, have I? Okay, it's kind of like these limit things, right? You gotta keep writing limit, 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 limit until you actually do your direct substitution. You gotta keep writing derivative, 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 derivative until you actually take the derivative and execute it. Okay. Anybody wanna gamble it? What do you think I'm gonna put first? I'm ready to take the derivative, so I'm not gonna write d over dx again.
Did you need to put the 5?
5 first, bracket. Yeah. Copy your oogie boogie, right?
No,
To the fourth.
4.
Okay, can I close my bracket and put it to the 4th? Now, I don't have to use brackets, I could put a little 4 right here, couldn't I? Means the same thing?
Mm-hmm.
It's clearly the power rule right here, so when you're first learning it, it's nice to see it as that exponent way up high. Now, bite into the chocolate, people, okay? Cosine of what?
2x cubed.
2x cubed. The angle never changes. Do you hear that? This thing here is never gonna change, ever. Throughout the whole problem, anytime you're dealing with the sine of whatever this is, whatever trig function you use, that will be the angle involved all the time. Never, ever, ever change your angle. I'm running close, aren't I? I see what you're saying. Now what?
6x squared.
Very good. Bit that peanut right there. Because the 6x squared is the derivative of your little mini oogie boogie. So you get your big oogie boogie, which is sine of 2x cubed. That got chased with cosine of 2x cubed. Now you need to chase it again with the derivative of the 2x cubed. So that's a double chain rule right there. And this final answer, I'm gonna write it here because I don't have room to keep going, is 6, oh, no it isn't, stop me. Boy, I put a 6, you guys help me.
30x squared.
30x squared, very good. All your coefficients come together here, multiply the 5 times the 6. The x squared would be nice. What now? I don't want any more brackets, so help me out, write it without brackets. I can pick C if you need me to.
Sine times cosine of 2x cubed
Sine,
times cosine.
Sine
Sine of 2x cubed.
sine to the 4th of 2x cubed, or sine of 2x cubed to the 4th, however you wanna say it, times
Cosine of 2x cubed.
cosine of 2x cubed. Notice that the sine function is being applied to the 2x cubed, and anytime there's a trig function in your answer, it is also being applied to the 2x cubed. Okay? We will dig into the 2x cubed, but we don't use the trig function again, right here when we take its derivative. All right, you ready to try a couple of your own? Can, oh, you know, I have another little thing I wanna mention to you. I'm gonna erase this, what's on the board right here with 1, 2, and 3. Anybody have any questions before I erase? You sure? No? Go ahead, whisper, I'll be very careful.
To the 2x cubed, yeah, the 6x, which is also 3 minus 2.
Yeah, I did a little power rule again right here. So this exponent comes down and multiplies by that 2, giving you that 6. Copy the base and take your exponent down by 1. Okay? Kinda like how I did this power rule. Brought the exponent down out in front, comes here, copy that base, clump, bring the exponent down by 1. But now you gotta take the derivative of the base itself, or your oogie boogie as I call it. So the derivative of sine of 2x cubed is cosine of 2x cubed, and then you bite into that little peanut and you take its derivative as well, 6x squared. Sounds good. Alright, so I'm gonna erase these, but I'm gonna show you something else that I think is kinda cool and it might be helpful to you. One of the places where everybody messes up sometimes, not all the time, but is with plus and minus signs. So I have this little trick here for you if you'd like. I say trick, you go, what? I say strategy, you go, oh my god, I wanna do another strategy. But this is a little trick. If you can memorize sine theta, cosine theta, negative sine theta, negative cosine theta. You can memorize that cycle. It's pretty easy to remember. Sine theta, cosine theta, negative sine theta, negative cosine theta. If you want to call them x's, you can. But you know theta automatically represents an angle measurement. So if you can remember that cycle, it's pretty cool. And it repeats, okay? So if you have to keep doing it, sine theta, cosine theta, negative sine theta, negative cosine theta. If you're going in this direction, these are derivatives. So if you're going down, which is what we're doing right now, those are derivatives. So the derivative of sine theta is,
Cosine theta.
and the derivative of cosine theta is,
Negative sine theta.
and the derivative of negative sine theta is,
Negative cosine theta.
and the derivative of negative cosine theta brings you back to,
Sine theta.
and it keeps going. Okay? So you don't have to write all of them, okay? You can stop after 4. I like to write the sine theta again, just so I don't have to hop back up. Right? But it definitely, right here, is a cycle of 4. Okay? So that'll help you a little bit in your future. And then when we get into chapter 4 and we do the antiderivatives, all we do is draw an arrow going up to reverse the process. Okay? But, so right now, those things should get memorized, and they should be in the notes. Okay, let's try it again. You ready for some? You can go a little bit faster here. What example is this? 4?
Yes.
Okay, so let's start with tangent cubed x. And I want the derivative with respect to x. I'm sorry I forgot to write that, you guys. Would you like it to be rewritten so the power rule is like in your face, or are you okay with just doing it without the base raised to the exponent? Okay, we leave it the way it is then. You guys are already going on it, aren't you? Okay, go ahead. Every once in a while, look up. Okay, look up and see if you got the same thing I had. Did you bring your 3 down? Copy that base of tangent x. Decrease your exponent by 1, so the 3 became a 2. You chase it with the derivative of tangent x, which is secant squared x. And if I wanted to eat that peanut, I'm not going to be very happy. Right? Isn't that peanut just x? I take a bite of that, it's just the number 1, I feel like I didn't even get any peanut. Okay? I can still do it, but it's not effective. Example 5. Get the derivative with respect to x of 5 secant to the fourth, excuse me, of 2x. The derivative with respect to x of the quantity 5 secant to the 4th of 2x. ready to see the power rule? Most likely not, huh? What's my first number I'm starting with? Yeah, 20. 20 what?
Secant to the third of 2x.
Anything else?
Times secant of 2x. And tangent of 2x.
We're on a roll. Peanut time.
Times 2.
Times 2. See that peanut?
Yeah.
Okay, so you crunch a shell when you take your derivative, you get into the chocolate with the chain rule, and then you get into the peanut, so you get your peanut M&M. Final answer.
Sixteen.
40.
40. Secant,
To the third.
Four. To the fourth.
and now have another one over here.
Oh, to the fourth.
So secant to the 4th of 2x, tangent of 2x. Wouldn't have seen that coming. Sorry. What trig function you want?
Cosecant.
Cosecant? Three cosecant of 5x squared. You need me?
Excuse me, I didn't want to I don't know if that makes
No problem. I'll make sure I get it.
Oh, no, thank you so much. Sorry to interrupt.
Okay, got 3 of you, okay, make sure you get good things. All right, one goes to you, one goes to each of you, okay? Okay. Oh, you guys have done this now, right, without interruption? What do you have? 3, say again?
3 negative cosecant.
Okay, 3 times negative cosecant
Of 5x squared.
of 5x squared
Times cotangent of 5x squared.
cotangent of 5x squared close again, chase it,
Times 10x.
times 10x. So give me a final answer on this.
30x.
Close. Help him.
What's that last name on there? That.
10x. 10x is my, I'd like to say peanut, but it's not. It's my chocolate, because I've only got the one derivative that I took, and then that chain rule right there. So I don't have to worry about too much. So what am I writing first?
Negative 30x.
Negative 30x. Cosecant of my oogie boogie, cotangent of my oogie boogie. Notice once again, for any of these problems, that whatever angle measurement I start with in the original question is the angle that all trig functions are applied to in all of the answer.
I know.